Hello everyone, this is Alistair here, and today's problem of the day is titled Matrix Operations. So let's have a look at the problem. So you're given a binary matrix containing zeros and ones of the dimensions n cross m, and according to the given operations you have to perform on the matrix, you are given that if the value of matrix ij is 0, then you have to keep traversing in the same direction and check for the next value. And if you get encounter a 1, then you have to update that 1 to 0 and change the current direction from up, right, down or left to the directions right, down, left and up respectively. And you will be starting from the 0 comma 0 cell and initially move in the right direction. So according to the example, here you are given a 2 cross 2 matrix and you will be starting from 0 comma 0, right? So you will be moving in the right direction initially, and then you encounter a 1 here, and this one will, since we were moving in the right direction, will change our direction from right to down, and that's why we are going down. And then we encounter a 0 here, but according to the condition, if you encounter a 0, we keep moving in the same direction. And after we keep moving in the same direction, we observe that our matrix, there are no further cells present, and that's why we ter- terminate the operation and return this particular last cell as our output. Now, in order to go about the problem, the main challenge is to maintain a state of our current direction and then update it accordingly as and when we encounter a 1. So in order to do that, let's jump right into the code and it will be much more clearer. So since we have to return the ij value, we have to return them in pairs. So we'll initialize our pair as pair with two integer values and name it as answer. And we'll also keep a track of our matrix size. So n would be the row size and m will be the column size. Also, to keep on incrementing and decrementing our, to keep on changing the directions, we would also have to manipulate our I and j values, that is the current row and current column positions. So for that we'll maintain a variable I and j, and for our state of the direction we'll maintain a variable or a character d and initialize with r, since we would be starting in the right direction at the in the beginning. Now coming to the main loop, I'll create a do while loop, and for the terminating condition we'll check if our I value is greater than equal to 0 and j value is greater than equal to 0, and also we would have to check if I is less than equal to the row size and j is less than equal to the column size. Now to go inside the loop, as and when we encounter a 1, we have to change our direction state, right? So let's move on with it. So we'll check if our matrix value is 1 or not, and if it is, then we'll update the matrix value to 0, and if our direction is up, then we'll change it to right according to the condition given here. If it is up, then we'll change it to right, and similarly we'll do this for all the other states. So if we were going right, then we'll change it to down. If we were going down, then we'll change it to left, and if we were at the state left, then we'll change it to up. Now that is done, we would also have to increment and decrement our I variable accordingly for both 0 and 1 case. So since the case for 1 is handled, that is the changing of directions, we simply have to check the directions again, the state of the direction again, and basically increment or decrement the j value accordingly. So for example, if my direction was or is r, I'll increment my j value, that is the movement from left to right, with 1. And if my direction is left, then I'll decrement my j value with 1. And if my direction is up, then I'll decrement my value with 1. And if my direction is down, then I'll increment my I value with 1. Now, as and when the loop is running, we'll encounter a terminating state when either 1 or 0 fails to satisfy any of the four conditions. For example, here in this case, we go out of the loop when our I variable was equal to n, or it was greater than n minus 1. And for that, we would have to basically restore the I value to this position, and we would do that by checking the state of the current direction. So it will be more clearer in the code. So for example, if we were going right and we encountered that if we encountered the terminating condition, and if we were going right, which means our j value became greater than m minus 1, and for that we'll decrement our j value with 1. And if we have our direction state as left, meaning we were going left, it would mean that our j value became negative, or it was less than 0. So for that we'll increment our j value. And similarly, if we encounter the direction d, that is we were going down, then we'll decrement our I value with minus 1. And if we were going up, then we'll increment our I variable. Now this is done. We have to now store the I and j value inside the pair, and for that I can simply assign answer dot first to be I and answer dot second to be j, and return the answer. Alright, that's it for today. If you have any doubts, you can ask them in the comment section. And thanks for watching.